Recording in progress.
Okay.
We're recording.
Wow. Well, yeah, wait, let me see if I can live on YouTube here.
I think I look too clerical with this Ukraine thing here. I'm going to move it.
Keep hearing the Russians are losing.
Let's hope.
Yeah. Oh, the cleaning people just arrived.
We'll go over at the end.
Nope. It's jumped back to Tom's YouTube account, even after I got it logged into mine. Okay.
Are we
proceed? I'll post the thing later.
okay?
Okay.
Recording right now, my friends. Hey, everybody, it is episode 62 of the weekly SBAU Astro Hour. Welcome aboard, everybody, you stargazers. Once again, we're going to address the latest discoveries in space, launches, probes, and satellites, a lot of astrophysics for the South Coast Longtime Telescope Club, the Santa Barbara Astronomical Union. I'm Baron Von Herren, proud to be Vice President of SBAU and your MC for the week of May 2nd, Monday through Sunday the 8th. And here's what we're going to try to get on board talking about, among many other subjects. We're going to follow some planets, mostly Mercury, little Jupiter, little Venus. There's a Venus-Jupiter father-daughter dance going on in the night sky. Shrinking moon has shrunk, and it's going to go near Ceres, the asteroid dwarf planet out there. Astronomy Day coming up in a couple of weeks, 1 week, this weekend, right after our meeting and other outreaches. A couple of comets, one of them is Halley's, the other is Pan-STARRS, and two tails, but only one of them is from a comet. The other, we're going to talk about a planet with a tail. Are you kidding me? Let's meet the scale back group. Our regular webmaster, ladies and gentlemen, is on another assignment, Tom Totten. So let's meet the president who's running the show, President Jerry Wilson. Hello, sir.
Good morning.
Got to see your lovely wife, Pat Forgy, earlier. She was in there as we launched a new version, number 62. And Chuck McPartland is our outreach guy, outreach
Good morning.
coordinator. Until I got rid of my cat, we all had kitty cats among the three of us. Jerry might be visited by his new one. What's the name of that one?
Princess Leia.
Oh, that's right. From Star Wars. I love it. And we're missing Tom Whittemore.
I think Tom tried to sign in, and I'm looking for how to let him in.
Well, if he saved last week's link from Tom Totten, he should be able to do it. That's what I used.
Yeah.
And Tim Crawford is probably not watching us, right? Because I don't know if we're signed into YouTube, but you can see us after the fact, right, gentlemen? SBAU.org is how you get in touch with us. I want to thank Colin Taylor, who is running secretarial duty, as well as remaining our treasurer, for sending out our monthly newsletter. And Jerry, I don't know if you want to call up your one cartoon, if you can do it or not, that you sent out. No?
No, which one was it you wanted?
Well, and so it starts. I can pretty much set the stage. It was headlined Prelude to an Intergalactic War. This is what we need to talk about in this day of Ukraine. Got the Ukrainian flag behind Chuck, who's married to our merchandise manager, incidentally, Pat. You're both married. Aliens have landed next to a pair of hardcore fishermen, and the space visitors just happen to be fish creatures. So maybe you don't have to post it, but that's the only one you got out. Are you running out of sillies?
No. It's just the organization on my computer here.
Incidentally, we're going to have our meeting this is number 4, isn't it? Our general meeting this Friday night, virtually, online. 7:30 to 9, I guess. And that'll be on YouTube, and Tom will be running that. And we'll have Dr. Ben Darvish, a renowned scientist and professor, I guess, at Caltech, talking about evolution of galaxies. We're setting him up. So, Schultz's star, talking points, Jupiter and Venus's father-daughter dance. I didn't really read far enough into that one. I wrote a lot down. The moon is passing everybody, including just south of Mercury.
The moon was at new moon on Saturday, I think it was.
Oh, so it's
And so now it's right. And so it went down last week in the morning sky. And now it's coming up in the evening sky as a thin crescent this week.
It was a nice little sliver last night.
Yeah.
okay, and it's gone by Mercury already.
It's
I think it was just below Mercury last night.
Yeah.
About what? Almost 2
I
degrees.
can't locate that funnies. It's not in my list there. I guess I omitted it.
All right, well, we'll get it so next week.
Okay.
So 10 a.m. Eastern Daylight Time, which would have been 7 here. This morning, it was 1.8 degrees south of Mercury. The slim little, this is the first new moon day, first sliver.
Well, yesterday and then today.
Yeah. It's a thin crescent right now.
Dumb question, but I'm going to ask it anyway. We have a full moon pretty much 3 or 4 days in a row. At least it seems full.
No, we only have the full moon at one exact minute. But it looks full for that day, and if you're not critical of how it looks, it can look full-ish for several days on either side.
Okay, so does it totally disappear for one day when it's changing over, waiting to waxing?
No, it's just fully illuminated. It doesn't go away.
Well, no. When it's new, it totally
Another
disappears again for an instant, basically, or for an hour or so. But it's close to the sun during the really, really slim phases, so it sort of goes away for a day on each side of new.
Right.
Okay, so today would have been the first day of the waxing moon.
Yeah. Well, last night it was doing it. It was visible.
Well, can we come back?
For some parts of the Earth, I believe we had a partial solar eclipse at sunset
Yeah.
on
Really?
Saturday. So that was how it looked for a short while, and that was no illumination at all.
Well,
And now, I've noticed, how there's this hype about blood moons. It's suddenly become a thing. Now that was called a black moon. And that is apparently now they're making it the equivalent of a blue moon. They're saying it's the second new moon in a month or the third new moon in a season that has 4 new moons. So it's kind of a new trending term that they're using for new moons, some new moons.
Aren't we going to have a lunar eclipse this month?
Yes, on the 15th.
Okay.
2 weeks after the total solar eclipse, and then we're going to get a total lunar eclipse.
Remember,
So-
28 days for a lunar cycle, 14 days or 2 weeks to get from new to full to new again.
Any plans to go out? And you probably all got to
Yes.
be focused on it, aren't you?
No, we have an observation planned, a public observation for the total lunar eclipse. It's on Sunday, May 15th, and we're going to be out at the Camino Real Marketplace from 7 p.m. to 10 p.m.
Oh, in the evening. Gotcha.
Well, you have total lunar eclipses when the moon is full.
Yeah, and that's only at night that we can
Yeah.
see.
The full moon's only up at night.
The what? What did you say, Jerry?
The full moon is only visible at night.
Oh,
Yeah, it rises when the sun sets.
Right, it's right opposite the sun.
well, is it possible to put the timeline in place for passing Mercury, which it's already done, and now Ceres, the asteroid, the dwarf planet, is coming up according to your talking points? When does that happen? When does the moon go just under Ceres?
I think that was Wednesday or something.
Last Wednesday or this coming?
No,
Wednesday?
this coming up.
Okay, so follow the moon across. What about this dance father-daughter thing between Jupiter and Venus? Or shall we do, well, let's save Mercury for the tail story as well, shall we?
Okay.
Yeah, the Jupiter and Venus were right on top of each other Saturday morning.
Oh, and-
Very, very close. And they're still close in the sky, but they're gradually moving apart.
Yeah.
And Jerry
Okay.
had a nice picture there showing, Venus and Jupiter and the moons of Jupiter.
okay, 21 degrees from the sun, eastern elongation. What does the
Yeah,
word
yeah.
elongation mean?
If I suddenly blank out, it's because my new cat is walking on the keyboard. She doesn't know the rules yet.
Hi, Princess Leia, looking for Han Solo, the tomcat from next door.
Yeah.
Elongation just means distance between them, Ron.
Oh, okay.
Usually from the sun. So it's usually used elongation from the sun.
And that's supposed to be at 4 a.m. Eastern time, so that would be 1 a.m. here. Shortly after sunset, Mercury will glow at magnitude 2. Is that bright? Can you see it with your naked eye? I guess you can.
Yeah.
It'll be 20 degrees above the western horizon, less than 1.5 degrees below the Pleiades star cluster.
Yeah, it won't be quite that high for us. That's for like 40 degrees north, but
That's good old M45.
it's not going to be easy to see. It was easier a couple of days ago, but it's heading downward and losing brightness. And we had a lot of haze last night, so it was difficult to pick it up.
That's right. We got an overcast morning today, the 2nd of May. How about Pan-STARRS C2021, C2021-03, the leaving the sun? What is it?
Here's Venus and Jupiter.
Oh, you did it, Jared. Thank you. Wait a minute.
Yeah. I'm learning how to, Tom had this down to a science, but I'm learning how to
Oh, good for you.
find things and get them up on screen.
Is this
So-
There's the double cheeseburger.
the real picture?
Yeah.
Yes, but it was taken in 2016, I believe. It's a previous picture.
Oh,
Under the comments are under the caption, in the caption and the talking points. So
okay.
it'll be like this. This is not an actual picture of it this year.
Jupiter would be the smaller because it's more distant? of these two?
No, Ron, look, Jupiter's on the right, much larger, and there's Venus on the left.
Yeah, see, Jupiter looks like the double cheeseburger.
Okay, if you say so. And where's Venus?
Venus is upper left.
Really?
And you can see the 4 Galilean moons there.
Yeah,
Okay, got it. All right. I thought sure Jupiter would be more distant and therefore smaller looking, but
Jupiter is huge.
I guess it is. You're right. It's
well, Jupiter is closer. Not Jupiter. Venus is closer and
Yeah.
can look huger or smaller. It has a big swing in its apparent size.
Yeah, and Venus is on the other side of the sun from us right now, but of course, so is Jupiter.
Yeah.
Venus, by and large, is yellowish orange, isn't it? There's no blue to it at all. Like
Bright white.
Oh, is it bright white? And it's a full planet. It's not a.
Not quite. It's not quite full right now.
Yeah.
It's only full when it's directly behind the sun from our point of view.
Okay, now Mercury is nowhere near these two, right? It's
No.
in a part of the
That's
sky.
correct.
Well, let's see here, capturing both in a single telescope field of view. Oh, it's going to be that close. Now, does anybody care about the comet? Are you guys looking for Pan-STARRS?
It's still a little too low for us.
Oh, it is? Well, it's at magnitude 8.5.
That's fairly bright.
All right, continue to pull away from the sun. Does anybody know why regular print PAN and then all caps stars, all one word, STARRS? What does that mean?
That's an
Yes.
acronym for their,
Okay, got it.
I don't remember what it is, but it's a long acronym for looking for comets, basically.
Well, it's designated 2021. I assume that means last year it was discovered.
Mm-hmm.
Dash 03, would that be March?
No.
03, just whatever. Put on it.
Pan-STARRS, can you see the screen I put up?
Yeah.
Okay.
Ron, that 03, that's an O, not a 0. So it's C/2021-03, and that tells you what part of the year it was found in, the 03.
It wouldn't be March?
No, it's
Oh.
not 03, it's 03.
Yeah, they just number things sequentially. That was the third one found in March.
Well, no, it's O3, and
Oh,
in
that's right. I fell into
2021,
the zero trap. Yes.
yeah, they start A, B, C.
Yeah.
A1, A2, A3. It tells you what something like what 1/6 of the year it's found in, and then the order it was found during that time period. So it was the third comet found during that time period, whatever corresponds to O during the year 2021.
Then they tacked on Pan-STARRS later.
Well, no, Pan-STARRS is the system that discovered it.
Oh, I see. Okay.
If you had spotted it in your scope, it would have been Baron 03, whatever.
Oh, yes, C 2021 O3 Baron.
Is that right?
Okay, yeah.
Well,
The sky in the west at the after sunset, you can see the sun below the horizon on the down here, and the Pan-STARRS is in this region over here below Perseus, and near Algol. It's about 8 degrees west north of the moon. The moon is shown here as a very, very small crescent, and this is for tonight.
Wednesday. This is for Wednesday?
No, this is for, see up here on May 2, it's today.
Okay.
So the talking point may have it for that date in there.
Okay. So at 8 p.m., the sky's going to still be bright because sunset isn't until like 7:45.
Right. You can see the sun is down here, and there's still this planetarium software still has a glow from it.
is that a real picture?
No, this is a planetarium program that shows you what you're going to see in the sky at a given time from a given location. And this is the one that I use to control my telescope, because I can go up to a set of menu items and I can have it find an object and focus on it. And then I can hit a slew button and my telescope will move to that object.
No kidding.
So this is an older version. This is called the Sky 6 from Software Bisque. It's an excellent software program, but then they came out with an excellenter one called the Sky X. So, and that one I use on my laptop.
Well, I do know that in our Gladwin Planetarium, there's a little silhouetted cityscape, if you will, or skyline around the edge.
Yeah.
Which I think even has the museum or maybe the mission or something.
Yeah,
it has the mission on one side. And it has the courthouse and the Granada building.
But is that what we're looking at?
No, there's a similar skyline on here, but it's just
it's a generic skyline. If I were energetic enough, I could take pictures of my own skyline with an all-sky camera, and it'll let me post it on there. I used to go to the Griffith Observatory, the planetarium there, every month for the change of show when I was in elementary school. It was a family outing, and they had a very detailed silhouette like that, and one out from where it was in Hollywood, the perspective of where the observatory is. And out in the region of the North San Fernando Valley, they had just tons of silhouettes of oil rigs out there drilling for oil, because that's where they did that. It's probably a collector's item. It's probably changed now, but it had all sorts of interesting stuff. I liked looking at it. Here you can see the moon as a small crescent, and below it, mixed up with all the names of the Pleiades, because Mercury is near the Pleiades, is Mercury with the name in red. And this is how close Moon and Mercury were at that time. Now the moon is moving up this way away from the sun. It did pass at an earlier date, but that was last week on this show, and I only showed now or future. So it did come past Mercury. It was down here, closer to the sun, about a day and a half ago, maybe a day ago. So that would have been a good time to see it. Now, these red things are, I can't click on them and show the name, but these red things are all asteroids. And I forget which one is which. This might be Ceres up here, but that's just a memory guess. Don't take my word for it. Oh.
some reason, I always remember you guys telling me, for the benefit of anybody watching us, and I guess maybe they're not at the moment, 2 degrees, oh no, half a degree
Half a degree.
is the moon.
Yeah,
And that means if you get 2 moons, 2 full moons side by side, that's 1/365th of the sky grid. It might go around.
right. 360.
Yeah. Oh, 360, not 365. I'm thinking,
Oh, that's a year.
thinking of the number of days in a year. You're right. So
That would be for the number of, well, it's not the number of moons, but it's closer to that for the whole year.
well, are we looking at the moon's crescent? Can you see the shadows in the mountains on the
Oh,
edge
yeah,
there?
wherever there's a crescent, there's a terminator, a line between the dark and the bright, and you can see dramatic shadows. Now, when it's a real thin crescent like this, you also can see the earth shine, which makes the dark side of the moon show up really well. So you can see the shadows on things that are still technically dark, but you can see the dark things too.
Yeah,
Well,
it's pretty much the best time to look at the moon.
Yeah.
what-
There's also a sort of a contest in the background among astronomers to try and take the photograph of the thinnest crescent you can get. And I think the limit is somewhere around 1 day old or less than a day old. It's a very thin crescent. I've had a very thin crescent pointed out to me in the sky, and they don't stand out. They're very hard to see unless your sky is, super, super clear. Okay, she looks like she's about to launch onto my keyboard again. So, oh, there she goes. Okay,
What causes the blood moons?
that's the name. That's just the name. Oh, well, it depends. When an eclipse of the moon looks red. Some people call that a blood moon. But there is one of the months I think is named a blood moon. For the full
Okay.
moon.
But it has to be full or close to full, doesn't it? You can't get a blood moon with a crescent, I'd imagine.
It has to be a total eclipse.
Right.
And is it partly the shadow of the Earth making it
No,
bloody?
it's the light from all the sunrises and sunsets on the Earth, basically on the moon.
Oh, is that right?
Because it's come around through our atmosphere, and our atmosphere has sucked out the blue light, basically.
Yeah, it acts as a prism, and it focuses the red light on the moon. It splits the sunlight in colors. It's just like the same thing that gives us red sunsets.
Oh, okay.
The red light is bent around the Earth, and you see the sky all red. It's all those red sunsets around the Earth that give the moon its color.
Okay, but eclipses don't always look the same everywhere on the Earth, do they? A lunar eclipse, one might think does, but maybe one area you could get the whole moon. Well, wait a minute. Would the whole moon be darkened no matter where you are on the poles, on the equator?
but yeah, wherever you are. But it just depends on whether the moon's currently over your horizon, whether you can see it.
Right. The moon might be set, and then you don't get to see it, of course.
Aye, okay.
So this one, we're kind of on the edge of where we're seeing all of totality.
Okay.
But points further to the west of us, I guess, are the ones that are going to miss some of it.
Aha, okay, then you verified what I was saying. And a solar eclipse definitely is only a track across the Earth, isn't it?
Right.
Full solar eclipse. Everywhere else gets partial.
Yeah, or none at all if you're far enough away.
Wow, fascinating stuff. Can we
So
talk?
that red dot I showed on the Finder chart is Ceres, the asteroid.
Is it?
Yeah, it was saying Eastern Taurus, so that's about right.
Yeah.
I've asked this before, but it's in the same class of planets as Pluto. It's a dwarf. Are they about the same size?
No.
I think you answered this before, and I don't remember. Pluto's a little bigger.
Ceres is about 600. Oh, wait a minute. Is it 600 kilometers or 600 miles? Anyway, it's on the order of 600 miles across, and Pluto's like 1,400 miles across. So
okay, gotcha. And Pluto has a couple of moons, Charon.
5, yeah.
But asteroids don't usually have moons, but
Quite a few of them are binary, but they're more comparable in size. So it's more like a binary system than it is a moon and an asteroid. Although, that DART mission is heading to an asteroid that has a moon, and it's going to impact the little asteroid moon and try to change its orbit.
Well, depending on the size of the planet or the asteroid and the moon that either orbits it or binaries it, it's all different, isn't it? I mean, sometimes they go around each other and it's not a moon. They're just two bodies, like binary stars, for example.
Well, it's really all the same. It's another one of those fuzzy things.
Yeah.
I mean, the moon actually, we're orbiting a common center of mass. It's not like the moon is the only one moving in our Earth's moon system. We move too, relative to the moon pulling on us. It's just a much smaller amount.
Okay. And what do they call that center of mass? Does it remain inside the Earth, or is it outside?
I think it's inside the Earth for the Earth moon system. Yeah, it might be more out toward the edge, but yeah, it's called a barycenter.
Does the sun react similarly to Jupiter?
Yep.
Perhaps it does.
It's got a wobble.
Whoa, fascinating stuff.
And to us, I mean, we cause it to wobble a little too.
Yeah. And so that's how aliens will find that our solar system has planets, by measuring the wobble of our sun.
Oh, okay. We use that in checking out stars for.
Yes.
Well, shall we talk about another meteor shower? We have more meteor showers than we do those variable stars. The Eta Aquariid meteor shower is from Halley's Comet tail, right?
Yeah.
Peaks early Friday morning with a dark moonless sky. Really? It's not going to be, or was that last Friday morning we're talking about?
No.
Okay.
I mean, the moon will have set by the time this peaks.
Oh, I see. I got you. So it is filling up though. It's on wax.
Yes.
It says
So this is May 6th at about 4 a.m.
Okay.
And the red circle, the red target up here, shows the radiant where the meteors will appear to come from. But they'll be all over the sky. They'll just appear if you could lay a ruler down on the track and trace it back, they'd all appear to come from this place.
Is that right?
Yeah. And so this is east. This is east southeast.
Okay. Does that mean Halley's passed through that point?
Yeah, sort of. That's where its orbit intersects our sky at that point.
Mm-hmm.
When's it due back? Does anybody know?
2069 or something like that. 2061.
Yeah, something like that. About 40 years. It's about halfway through its cycle, roughly. It's way out there. I saw a picture of it about 2 years ago when it was way out there, and it's through one of the 8-meter telescopes on Mauna Kea, and it was just a dot on that photograph.
Yeah, it's going to be 2061 because it's about a 76-year orbit, and it was 1985 last perihelion, I think.
Okay.
So Friday night, when we used to be meeting live, we could have all gone outside and watched meteors.
Well, this is a little later after than our meetings are. That's
actually, it's earlier than the meeting because it's the morning of the day of the meeting.
Oh, that's right. Okay.
But doesn't it go several days and just peak?
Okay.
Yeah.
Okay.
You want to catch the peak, but yeah.
Yeah.
And you also 6 months later, the Earth hits the orbit again, it turns out, and the Orionids in October are pieces of Halley's Comet too.
Mhm.
So that radiant you pointed out, Jerry, is in the Aquarius?
Yes.
Yeah.
And that's why it's called the Aquariid with two eyes, meteor shower. There's also
Pluto is way over on the right. You can see
it is.
it's near M75, which is a photo op. They're about half a degree apart.
Wow.
And these other red dots down here are named asteroids. I don't recall the names. I should have written them down.
It's busy up there.
Yeah.
Well, our outreach coordinator happens to occult asteroids when they block out a star. Have you done that recently, Chuck?
A couple of nights ago, yeah, but it was a negative, or it was in the morning, but it was negative.
Wasn't Ceres involved in an occultation or occulted by the moon?
Yeah, there's a potential occultation of Ceres when the moon goes up there, but not for here, but for parts of the Earth.
Yeah.
But for some places on the Earth?
Yeah.
Wow. Gee, you'd think that moon would be big enough that everybody on the Earth could see it happen.
Mm-hmm.
Only 250,000 miles away. Some Dutch Bia, what's the heck is the name of that star? Sadakbia Gamma Aquarii rises in the east at 2:30 a.m. Pacific time. An hour and a half later, it'll be 17 degrees. That's the radiant we were talking about there. So,
Yeah,
but it brings up an interesting note that Mr. McPartland noted and found online and sent it to Jerry, our president. The sodium tail of one of our planets. Tell me this isn't so. Planets now have tails like comets, at least one of them.
Yeah, well, there's stuff that there's a solar wind coming out from the sun and it blasts off pieces of the atmosphere. So we leave a tail behind. But it's mostly from stuff in our atmosphere. But in this case, it's Mercury, doesn't have an atmosphere, doesn't have a magnetic field to protect it. And so you get sodium atoms blasted off the surface by the solar wind.
Sodium. Is it
There
salt?
it is. It's near the Pleiades. That's a great picture.
Is it sodium chloride? Is it salt?
nope,
Oh, it's
Just-
sodium.
just pure sodium.
And that's what we're looking at. That's the planet Mercury with a tail.
Yeah.
Yes, but you won't see this with your eye. This is taken through a special filter that enhances, it lets in the light from sodium only.
Okay.
So the other things you see are suppressed a bit, or they have sodium in them too, but not dramatically like the Mercury does.
Is that one of the dippers above it?
No, that's
The
the
Pleiades.
Pleiades.
Oh,
It's
that's the
sometimes,
Pleiades.
it's
Okay.
sometimes confused with a Little Dipper.
Ah, there
But
you
it
go.
would
More
be
like
a
a
teensy
micro dipper.
Yeah, micro
Okay.
dipper.
If Mercury had a metal interior or a magnetic field, would we be seeing that, you suppose, that tail, or would it
Less
disappear?
so, because that would tend to deflect at least the charged particles coming from the sun.
Okay. But how far out does it go? Do they know?
Oh, I think it's a couple of million miles.
Yeah,
Oh, man. But there's no chance we'll ever pass through that and get a meteor shower. We'd have to go.
No, these aren't chunks.
yeah.
Wow,
They're
fascinating.
atoms.
Now, all these meteor showers, every time we turn around, we're getting a new one. We're going through a comet's tail, right? When that happens?
Yes, generally, yes.
And
Well, we're going through a tube of debris left behind in its orbit from the tail and stuff blasted off, but it's not actively the tail anymore.
Yeah,
most of what the comet ejects is just water vapor, isn't it?
a lot of it is back in the 1800s, 1870s or something, when Comet Halley went by very dramatically by the Earth and fairly close. When its tail was dramatic in the night sky, astronomers were developing spectroscopy, and they had looked at the tail and they'd found all sorts of chemicals in there, among them cyanide. And so the press got a hold of that and did their sensational positive feedback thing. I forget what that's called now, but frenzy. And so people took advantage of that, and they were selling gas masks, don't get, because everybody knew that cyanide was a deadly poison. So they hyped it up and made a bundle off of it.
Cyanide is not an element, it's a compound.
It's a molecule. But just like mercury, or mercury here is giving off molecular sodium, this stuff is out there in space, and it doesn't produce, as Chuck says, it doesn't necessarily, the molecules don't produce the meteor shower, but they do contribute to sky glow, and or the Gegenschein, and what's the other one that comes up?
Well, dust.
Yeah, the dust, there's a reflected, sunlight is reflected off of dust.
Yes.
Sometimes.
In the evening, in the morning, you see a big pyramid of light.
Yeah.
And it has to be a speck of dust to make a meteor.
Yeah.
Just the
You need a fair amount of mass.
Yeah, you got to have something that'll burn up.
I've heard the term potassium cyanide. Does that mean that
There's
potassium?
different types of cyanide: potassium cyanide, sodium cyanide.
Oh, okay.
Each one's more deadly than the other.
Well, look, we're looking at a tail of what is it? What part of salt is sodium?
Sodium, yeah.
Is there sodium all over the surface of Mercury?
Yeah.
Not as much now.
Yeah. It's getting depleted by this.
Yeah. There's all sorts of chemicals on Mercury. You can take pictures of different things, the planets, especially the moon. I've seen very, very colorful pictures of the moon where the natural color, which looks all whitish gray, is enhanced to show the chemicals that are there. And they make very pretty pictures, but you can tell what the dominant mineral is in that part of the moon and likely where its source was. We showed one of those about a half a year ago or something.
Uh-huh. Wow. No chlorine, no. No salt. I thought salt was
Not so much, not so much, no.
Yeah.
So let's look at the core of the galaxy.
Oh, yeah. Where would that be here? The core, that's early May morning. The center of the galaxy, Milky Way, sits in Sagittarius, prime display.
Yeah.
A few hours after
Remember in
sunrise.
the other one at 4 o'clock in the morning, Pluto was on the extreme right. Now we're looking to the right of Pluto. And this is early morning, just before sunrise. And it's a harbinger of what's to come for the summer constellations. This with just loaded with Messier objects, but it's basically looking right straight at the core of the galaxy. You can see the central bulge of our galaxy, and then the edge-on arms and dust clouds going up to from lower right to upper left.
Uh-huh. Be interesting if we were in line with that ecliptic, wouldn't it? Everything would be along the horizon, wouldn't it? If we were.
Oh, if we were tilted right?
Yeah, if we were in line.
Well, actually, Ron, you can see that in May evenings, the Milky Way is right around the horizon, and we're looking out toward the North Galactic Pole, which is up near Leo, kind of near the tail of Leo in Coma Berenices. And so the Milky Way is going around the horizon. We're looking up out of the galaxy. We don't have all this stuff in the way. And that's why the Virgo cluster and all that, this is prime galaxy hunting time.
Uh-huh.
Because you can see out to those fainter things.
And somehow science has determined they know what kind of galaxy it is. It's a barred spiral with 4 arms or 2 arms.
That keeps bouncing around.
They don't know.
Well, yeah, I mean, periodically you'll say, no, it's only 2 with some spurs. And now they're saying, oh, it's more. So it just depends on how well they manage to map some of these clouds of hydrogen gas.
Uh-huh.
And here comes probably, here's the latest one. So depending on what you call an arm, there are sort of those 2 really major arms that come off the end of the bar.
Yeah, right. I see that.
And then see how it says Sagittarius arm there, and that
one and this one.
Yeah.
So then there would be 2 spurs in between those arms. We're in the
origin. You can see they're calling the Sagittarius arm that one that you might have called a spur that's coming off of the Centaurus arm.
Oh, I see. Yeah.
Yeah, that's this one. And then there's another one that sort of starts in here and goes up around there.
And all the way around out here, outer arm.
Huh.
So this is one of those things where it kind of depends on what you want to call an arm or not.
Yeah.
It's like saying, where's the edge of that?
But the arms don't keep the same stars through their whole lives, do they? The stars go in and out of them somehow. It's amazing.
Stars are born and die. And the arms represent, they have a lot of red nebulas in them. You see, that's star birth going on in there. That's where stars are born.
And they're orbiting, okay? And so they're born and they die because they tend to be massive, being born in those clouds.
Yeah.
And they live fast and die young. So the width of the arm is kind of the lifetime of some of these massive stars.
Yeah, and you see the haze between arms and stuff. That's clouds of stars that are longer aged.
Really?
Lower mass stars that live longer.
Right.
But our solar system goes in and out over the eons, in and out of these different arms.
We're right here.
Okay. Oh.
In the suburbs.
Yeah, in the burbs.
In between. Do you know how long it takes for the Milky Way to make a complete revolution?
At our radius, it's something like 225 or 250 million years.
Yeah.
Uh-huh. So you could probably figure out how many times it's rotated in the life of the universe, couldn't you? 13.5 billion years.
I think the number is about 17 times around for our sun in the sun's lifetime. This galaxy was here before the sun, but once the sun was born, it's been around about 17 million years. And the latest meme is that when we were on this side of the sun over here, that dinosaurs were on the Earth.
Well, for crying out loud, geez.
110 million years ago or something.
And we are moving like a NASCAR race, aren't we?
Yeah, you just got to define relative to what?
Yeah.
Well, they don't ever say that. They just say 600, 800, 1,000 miles an hour, you know. That's how fast we're turning anyway on the equator, but I think we're moving.
That kind of stuff can leave you confused sometimes. A light wave coming by travels at the speed of light. But if you were the light wave, then the entire universe is moving the other way at the speed of light. So.
Ooh, you lost me there, Jer. I'm sorry. I understand the shortening to infrared. That's why we got the old web out there. The web's.
Yeah.
I have to talk about an update on that here in a minute. That's fascinating stuff.
Oh, yeah.
So there are galaxies with 4 arms, but we happen to be a 2-arm.
We're at 2.5.
2.5 arms.
Yeah. We have 2 prominent arms.
Yeah, yeah. And there were at least four of those that labeled on that diagram that called it an arm, 4 arms. So it's another dwarf planet, major planet type argument.
Well, I just don't understand how the stars move in those big furball. What are they called? The ones that don't.
Globular clusters. Yeah.
No. I'm talking about galaxies.
Well, elliptical galaxies are similar things.
Elliptical. I wonder why they call it elliptical. I'd call them cotton ball galaxies. But
well, they're shaped like ellipsoids.
Ah, okay. There's some monsters out there, big ones that would dwarf us. Anybody know about the James Webb, where we stand in telescope alignment? Is it done? Complete?
Yep, it's done. So these are the near spec is the guidance system, I think. I don't have my list right in front of me here.
Well, there's a fine guidance sensor below it. That's probably the guidance sensor.
Oh, yeah. Pretty sneaky putting that right up front. Yeah, so that's the guider. The other 4 things are cameras, different cameras in different systems. And each of them has been calibrated. And these are the images that it takes, showing the details for the guidance systems. The near IR spectrometer on the left, the near IR cam on the middle, the mid IR imager on the upper right, and the near IR, I forgot what the SS stands for, but it's a pretty picture. So there's a few more, about 2 months of data taking and engineering, truing in, or whatever they call that. Yeah, before we get into hardcore science. But the images are quite spectacular. It's absolutely an amazing achievement.
That's far more stars in every one of those boxes than the Hubble could see.
Well, yeah, because these are all in the infrared. Hubble would not see these stars. At least
even if they were close.
The brightness would be very different. Which ones were brighter and which ones were dimmer, and some of them wouldn't be there.
Mm-hmm.
Well, there's a chance if it zeroes in, and I assume it has that capability of coming in like on the deep field.
Yeah.
You're still going to see this, millions of galaxies and stars, and it's like an embarrassment of riches. There's two.
Yeah.
Well, they're going to love it,
I suppose, but how do you zero in on any one of those stars that you might want to look at? Can it do that?
You point the telescope. Though.
Yeah, you point the telescope and take a picture at maximum magnification.
Uh-huh. Are we looking at basically the same area of the sky, just taken by different sensors and lenses? And
that I don't know.
I was trying to look and see if any of the patterns matched up, because they're likely to be at different magnifications.
So there's a star right there. Do you see my cursor?
Yeah.
And then sort of a T asterism there.
Yeah.
And
Okay.
here's a star, and
Yeah.
you don't-
That looks like the same area. Yeah.
yeah. And this
Okay.
might be the same area here, but I don't see that pattern right off in the other ones. Oh, there it is, right there.
Boy, look at this. If they ever program that sucker to do a deep field, it's going to be awesome, isn't it?
Mhm.
Oh, yeah, I'm sure that they'll look at, I'm sure they'll do one.
Probably won't take as long as how many months or weeks or
I think
6
there was
weeks?
100 hours in the deep field.
Uh-huh. And you got to find a place that's kind of blank in the sky or void and
Yeah.
difficult.
Otherwise, you just get a white sheet back.
Wow. Star-rich region, the Great Magellanic Cloud is what we're looking at. That must be one of our satellite galaxies.
Yep.
Fascinating. Well, you want to talk about the Leo Triplet? I figured that out finally, I guess. Leo the lion reigning high in the southwest after dark, slowly making its way to the horizon, but won't set until early morning tomorrow. So zero in on the regal constellation Leo, the lion. It's got 5 Messier objects out there. Messier, all galaxies, 65, 66, 95, and 96, and 105. The brightest one is 66 at magnitude 8.9. So it's about 2.8 degrees southeast of magnitude 3 star Cherten. Is that the name of it?
Hmm.
In the lion's hindquarters. So Leo's triplet of galaxies apparently is what? 66, 65, M66, and M65, plus NGC 3628, which is not a Messier.
That's correct.
Yeah, that's up here in the upper right.
The hot dog.
Yeah. Or
The
hamburger.
hamburger.
Yeah.
That's a galaxy seen side on.
Yeah.
Interesting. And
And they're apparently interacting, so
Messier couldn't see that one.
or didn't bother to write it down.
Yeah. Yeah, he clearly missed that one. If you look at it, the two M65, M66 look brighter to me and they're more concentrated. The other one, the hamburger, is spread out more and looks a little dimmer. So apparently he just missed it.
And he might not have had the field of view to catch them all at once, like this picture shows. So
Yeah,
he
that's
would have been
true. Yeah.
moving from one to the other, and it's easy to miss things nearby.
Uh-huh.
It doesn't have another common name like sombrero or cat's eye or something like that.
Well, I've seen it called the hot dog, and Jerry's seen it called the hamburger.
Barbecue season.
Yeah.
Yeah.
And so those 3 are an asterism?
No.
Mm,
No, just part of the
a
constellation.
Those are-
galaxism.
Yeah, those are a galaxism.
Well, where are 96 and 105? And
There are many fields of view away from this triplet.
okay, those 2 on the lower right are stars, I guess.
Yeah.
Yeah, and the orange one up at in the middle. That might be a no, I think that's a star too.
Orange one. I don't see orange on my screen. The hot dog is kind of orange. Huh.
Yeah, most galaxies, when you image them, they're all assigned colors basically, but if you do it a certain prescribed way, the cores of galaxies, the bulge and stuff appears to be yellowish, and the arms of the thing become bluish green or bluish, indicating new star formation versus old stuff in the middle.
Uh-huh. And it's 35 million light years away, which would definitely put it out of our local group, wouldn't it?
Mhm.
Yeah.
Not part of our local group. Is there a satellite galaxy to us called Triangulum?
It's
It's a
in our local
constellation.
group.
What?
Yeah.
There is, okay. I thought I heard that somewhere. Getting down to the wire, got about 10 minutes to go. What did we, Schultz's star. We got time to talk about that. I've never heard of Schultz's star. Who, is there somebody named Schultz? The
Yep.
Jewish name?
Yes,
A binary that came by us.
it's right here. It's right here.
Okay, it's
No. No, that was me talking to my wife. Forget it. I didn't mean to yell no at you guys.
bless her heart. Well, Apparently, there was a dim binary star that probably went through our Oort cloud, I think, many, many years ago, and shook things up. Mr. McPartland told me before we went on the air that it might have affected our planets, but mostly it hit comets and asteroids, and it's a binary pair of a red dwarf and a brown dwarf called Schultz's star, even though it was misspelled at one point as Choltz with a C, not an S. SHOLZ''S.
Oh, yeah.
Okay. Also known as WISE, WISE 0720-0846. 70,000 years ago, it approached us. What do you know about that, Jerry or Chuck?
Well, it would have come, if it's 0.8 light years, that's within some definitions of the Oort cloud. And so it would have disrupted these things that were potentially in stable orbits around our solar system and caused them to come in or out.
Given us comets.
Yeah.
Where is it now? It's still out there somewhere. We can look
Yeah,
at
it's moving away now. It made its drive-by shooting and it's on its way out.
And they could calculate 70,000 years ago.
So this is a schematic sketch of our solar system with the sun in here and our planets.
Okay.
And this is the Kuiper belt as a disk. And then as it gets out here, this is the part of our original sphere of particles that became a disk and then became our sun and planets. And this is part that has not yet lost its circularity. And it's called the Oort cloud. And it is this part that Schultz's cloud star passed through. It didn't have to actually hit anything. If it hit something, they'd still be part of Schultz's star. But it passed near them and it perturbed their orbit. And it gave them
ripples,
What'd you say, Chuck?
It caused ripples basically in the orbits of these things.
Right.
And so some of them got tossed out, some of them got tossed in.
So if it were a larger star than a red dwarf or even a double binary of sun-sized stars, it would have done more damage, wouldn't it?
Yeah, there'd be more effects.
Yeah.
Also depends how fast it's moving.
You know what I've always wondered, I brought this up before, why are the star systems, stellar systems like our solar system all flat and all the planets are in the same plane? Why don't they look like atoms? Why don't the planets go
Because
everywhere?
they form from a cloud of gas that tends to have some net angular momentum, some net rotation to it. And things end up collapsing down into that plane by conservation of angular momentum.
Okay, and this is all happening, carving out a bubble in the middle of the dust that was there in the beginning.
Mm-hmm.
And that dust shell, the outside part, becomes the Oort cloud.
Mm-hmm.
How does it get solid bodies in there and go from dust to, God knows, rocks, I guess, like asteroids?
Well, when they collide with each other, they accrete.
Yeah.
They do.
Especially out there where they're slow moving, they would tend to stick.
Yeah.
I just find it hard to believe that at that small of a size, there's enough gravity to make them into a rock.
Well, it's not gravity in many cases. It's just electrostatic forces.
Yeah, they get close enough.
What are we looking at here?
This is showing the difference that all orbits of every kind are conic sections. And that is, you can get these different curves by taking a cone, a solid cone, and slicing through it at different angles.
Right.
So if you had a Oort cloud particle that was in a circular orbit around the sun, then if Schultz's star passed inside of that going this way, then it would take that circular orbit and it would give it energy, so it now was in this type of a big elliptical orbit. Or it could give it more energy and put it into a transition from a circular to a hyperbolic orbit, and that's not closed, so that would leave our solar system.
Yeah.
And if that star happened to pass coming in the opposite direction in which things were generally rotating, then you'd have the effect of making the orbit smaller and causing things to fall in.
Yeah. Then the Yeah, then the orbit would become elliptical, but with going inward. Oh, wait a minute.
But the most common orbits, the most common are probably elliptical, right? There's not too many circulars.
Right.
Yeah, eccentricity is the measures the ellipticalness. It's something with an eccentricity of what 0 is
The circular.
circular orbit.
So it's sort of a special case.
Yeah, which we almost fit.
Yeah.
Can you cut a hyperbolic out of a cone by going straight down the side without going all the way through?
Yeah, you go straight down parallel to the long axis of the cone. You know, the cone sitting on the table pointing up.
Right.
Axis points up. You slice down parallel to that axis, you get a hyperbola.
And that would have been the path of Oumuamua.
Yes.
Oumuamua came and left on a hyperbolic trajectory. The fact that it's a hyperbolic trajectory is how we know it came from interstellar space. And they're generally traveling at very high speeds.
Ah,
If one of those hit the Earth, we would be very unlucky.
yeah. I keep hearing that we're.
And actually, there was one that hit the Earth.
Yeah.
They've now identified the first extrasolar object that came in and hit in like 2017 or 2014, before Oumuamua.
Yeah.
But the radar data on its trajectory was classified. And it was something like 1 meter across, and it hit in the upper atmosphere and gave a blast, you know, a detonation, like we get from solar system stuff too, but just a little more energetic for the size because of the velocity it had.
Is that Russia?
No, that was the Chelyabinsk impactor.
Yeah.
That was just a local thing.
Oh. Well, there have been some bad ones in Russia, 1908, for example.
Yeah.
And then recently we had a bad one break windows and really lit up the sky. But
Yeah, that was Chelyabinsk.
they think they're from, how do they know they're extraterrestrial or extra solar? They're out of,
Because of their orbits.
oh,
And they had tracked this one with a classified radar system, and they had its speed and its orbit, and they just didn't let the news out until recently because they didn't want anybody to know that we had that capability.
just like we're monitoring and cataloging exoplanets up to 5,000 now. Are they doing the same thing with rocks that might hit us?
Oh,
Sure.
yes. Matter of fact, that's the prime mission of the new Space Force, which
Is
was
it?
peeled off from the Air Force, which originally started it as a planetary defense mission, which was not to defend us against Mars invaders, but to defend us against asteroid. You know, as they say, there's no dinosaurs today because dinosaurs didn't have a space program. So comets perturbed from the Oort Cloud would need nearly 2 million years to reach the inner solar system. So from the passage of Schultz's star, we haven't seen the results of that yet, but other ones have come as close. And it's estimated that a star similar to Schultz's star trajectory will pass through the Oort Cloud every 100,000 years or so. So, and that's one of the things that is a more of a hazard to Earth than these near Earth asteroids are. Because the near Earth asteroids, we can track them and we know their orbit. Nothing is stable. Their orbits change, and so if one of them changed like Apophis, so that it comes close to Earth, we will see it in time, hopefully, to do something about it. But something that's on a one-time trip to the Earth in a hyperbolic orbit gives us less time, especially comets. So a comet will show up a couple months or a year in advance, and that's not a lot of time because we can see asteroids becoming a hazard about 50 years out, probably. So
if we get a hyperbolic visitor, there's not a SpaceX on the planet that would meet it and deflect it.
they might attempt a landing.
The DART out of our county, right? Was that the one that was trying?
Yes.
Okay, DART. I forget what that stands for, but
That was
definitely.
the demonstration asteroid redirection test.
You don't know who Uman Schultz was, huh? That's got to be the name of the astronomer who found this out.
Yeah.
And what
Yeah,
is,
sorry about spelling it wrong. C is close to S. So,
Yeah.
that's true. That's what Chuck
so I
said.
think that's our time for today.
Pretty much. Well, we were 2 minutes late. You recall?
Yeah.
Just tell me what constellation Monoceros is before we go.
It's a unicorn.
Oh, Monoceros, one horn. Ceros
Yeah.
means horn. Interesting. Well, gentlemen, it's been interesting, and let's do a quick recap. Friday night this week on the 6th, our speaker from Caltech will be Dr. Dervish, talking about the evolution of galaxies. Tom Totten, our webmaster, is back in charge of the web and other things, and SBAU.org gets you everything you need to know. If you're a member, by golly, I guess we're accepting donations again, aren't we? Or money
Membership.
to membership.
At
fee.
our next business meeting, 2 weeks from last Saturday, we will discuss starting the dues again.
Actually, 2 weeks would be 2 Saturdays away. This last Saturday was the 30th.
Right.
Right, so
Right.
So
2
it's
Saturdays.
On the 14th, on the Star Party night.
That's right.
Yes.
And
Yeah.
happy Mother's Day, especially to the wives who, I guess you don't have any children, Chuck, but you're like children yourself. We'll see you
I've got
around.
one sitting right here on my
Yeah.
shoulder.
And Bruce Murdoch, get better, my friend. I understand he had an accident Friday night or Saturday night at the Girl
Saturday
Scout
night.
March, Sunday night. We'll do this again. Jerry, good luck getting us down and out of here. I have full confidence you're going to be on top of this. You and the cat, Leah, Princess
Yep.
Leah. All right, everybody. Thank you from the Santa Barbara Astronomical Unit for the SBAU Astro Hour number 62. We'll do it again next Monday morning,
Okay.
morning of the 9th. Thanks. Take care.
Thank you.
Bye.
See you, everybody. Now we should be clicking off on something here.